Cape Town, so I'm very happy to be here in South Africa. In fact, it's my first time in South Africa and also my first time in Africa even. So originally I am from Austria, and so I want you to imagine a typical Austrian winter. It's not like here, where for us Austrians, at least, it's quite warm, I think. Although yesterday I heard that it's also already quite cold for the locals, but yeah, whatever. But in Austria, it looks more something like what you can see here. So it's cold outside and it's snowing a little bit, but recently it's mostly raining, unfortunately, because of climate change. But yeah, it's gray outside and dark and uncomfortable. And I'm visiting my mother because it's holiday season. And just disclaimer, this is not really my mother, this is what this is what AI expects my mother to be. And she really is into coffee because she has even 2 cups of coffee. So, but although this image is fake, the story is real. So I'm visiting my mother for holidays, and she's browsing the web on her iPad, and she's looking for a vacation. She is looking forward to relax a little bit and flee the gray and rainy weather outside. So she's browsing the web, and she finds a nice-looking hotel, and she already wants to book it, but the price is too high, so yeah, she keeps searching. So another 15 minutes or so pass by, and she keeps searching for a nice vacation, and then she finds the perfect, or it looks like the perfect vacation that she finds. And the price is good, and the hotel is fine, everything looks good. So she decides to press the checkout button, and then this happens. Just a blank white page. So what could be the reason for this? In this instance, the reason is that she was using a very old iPad with an old version of Safari. And as an industry, the last couple of years, we decided to build more and more single-page applications. And single-page applications rely very heavily on JavaScript. So a single line of JavaScript that is not supported in an old browser, for example, can lead to something like this, breaking the whole experience, leading to my mother not being able to buy this nice vacation, and the owner of this website not getting any money, unfortunately. So a problem with single-page applications can be that they are very fragile. So as I said, a single line of faulty code can cause something like that. But there are also other problems. One of it is that we tend to neglect accessibility, because by building client-side, JavaScript-heavy client-side applications, it's very easy to neglect accessibility, because it's very easy to do stuff like that, to use a div instead of a button element, for example, for something that should be clickable. Because when using JavaScript, we can simply slap an on-click event handler on it, and it works, kind of works, but only for people using a mouse, not for people using a keyboard, for example. So if you want to learn more about the accessibility stuff, then you can watch the talk later by Lucky. I think it's in the afternoon, where he talks about how we can automate accessibility testing even. But for this talk, accessibility is not the only problem we often face when building SPAs. There is also complex code in general, but more specifically complex state management, for example. But this is only an example for how complex a code base can become when we build single-page applications, because we don't have very mature framework, or we didn't have very mature frameworks up until only recently. So we oftentimes see things like that, like having deeply nested context providers in a React application, for example, because each of these context providers provides some global state we need for our application. And also in other frameworks like Vue.js, for example, we also see very complex code or very complex state trees like this one for a Vue.js application with Vuex or Pinia. But this is still not the only problem. one very big problem, and I'm sure many of you saw this probably in their own applications, is that of bad performance. With single-page applications, it's also very easy to build poorly performing applications. So many of you might have seen something like this when they run their lighthouse tests on their own applications. And a typical sign for a JavaScript-heavy single-page application is the total blocking time. So having a very high total blocking time is oftentimes correlated with having very big JavaScript bundles, which is often the case when we build complex single-page applications. But now you might wonder, how did we even get there? If there are so many drawbacks with single-page applications, why did we decide to go this route? Why did we even decide to go this route? So for this, I want to quickly go through a short history of the web in general. So somewhere in the year 1990, Tim Berners-Lee came along and he invented HTML and basically invented the web as we know it today with it. And at that time, we had static HTML. Not even CSS and no JavaScript at all. So those were the simple times where everything was nice still. But then somewhere around the year 1995, we decided we need some more dynamic, we need to do some dynamic rendering on the server side. So there were a couple of server-side languages invented around this time, like many of us maybe still know PHP, and maybe still use PHP, and we had applications we had web applications that run their logic purely on the server side, and the server spit out some HTML and sent it to the client. And this is what we today call multi-page applications. At those time, they were simply web applications or websites, but today we tend to refer to them as multi-page applications as opposed to single-page applications. So with this multi-page application stack, we have a couple of advantages, but also disadvantages. First of all, progressive enhancement is basically baked in. So by progressive enhancement, I mean that the minimal experience, or the bare minimal functions like a checkout page, for example, work just by using the server-side logic without any enhancement that we do with JavaScript logic in any way. Also, those applications can be very resilient, or typically are very resilient, at least compared to single-page applications. Because with a single-page application, there are many things that can go wrong where we don't have any control over them. Like they can fail on the client side for a multitude of reasons. They can fail because the JavaScript does not load, they can fail because the JavaScript does not execute correctly, and so on. With multi-page applications, everything runs on the server, and as long as our servers work correctly, everything also works for our clients or for our users. But there are also drawbacks, like we have full page reload. So every time we navigate through our application, we always have to do a full page reload, and when we submit forms, we also have to do a full page reload, which is not a very nice experience, at least for today's standards where we are used to native applications and stuff like that. And also there can be very long server response times, because if we have to generate all the HTML up front on the server side, we need to fetch all the data we need to generate the HTML. So we need to fetch all the data from databases or maybe even other API endpoints. And this can take a long time, and leading also to a very poor experience for the users. So in this example, we can see how a typical purely server-side rendered application might load. So what we see, the screen is white for a long time, and then everything pops in at once. So if we have a slow connection, and all of those videos you will see are on a simulated 3G connection, it takes a couple of seconds until we see the first content, because the connection is slow, and it takes a while until we have successfully fetched all the data we need to render this application. So time passes, and somewhere at the year 2005, we come up with something called AJAX, so asynchronous JavaScript and XML. And with Ajax, it was possible to do some fancy tricks, so we could load data on the client side instead of only loading data on the server side. And with that, it was possible to build more app-like experiences and have a little bit nicer user experience in general. And this all accumulated in the year 2015, or around the year 2015, when we had fully fledged SPA frameworks like Angular, like React, and Vue.js, and so on. And now with those frameworks, more and more we started building applications that only render on the client side, so there is no server-side rendered HTML at all anymore, apart from the bare minimal HTML tag and the script tag. So we had single-page applications, and why did we go that route? Because we have a couple of other benefits, but also a couple of drawbacks, as we already saw at the beginning. First of all, we have a very fast initial response time opposed to server-side rendered applications, because we don't need to do all the data fetching on the server side, but we can do it on the client side, or we can mix it even. And most importantly, we get a very app-like experience. So everything is interactive, we don't have to full page reloads anymore, and it feels a lot snappier, and yeah, it really it works the same way as we are used to from desktop or mobile applications, basically, if we do it well. But there can be a problem with waterfall loading, because although we have a very fast initial response time, at some point we need to load all the data, and at some point we also need to load stuff like CSS, for example. So first we need to load the initial HTML, then we can load the JavaScript bundle, which can be very big, which can take a while, and then we might even need to load the CSS or fetch some data. And as we saw at the beginning, single-page applications can be very fragile because there are so many things that can go wrong on the client side, opposed to the server side, of which we have full control. So let's see how a typical single-page application loads. So I pause here for a second, so we see we can show a loading spinner. This can be a little bit more fancy, like this. I only show a loading text, but usually you might have a skeleton page or some kind of app shell or something like that. But the important thing is that after 1 second, we can already show something, at least. Nothing very useful mostly, but at least something. So we have very fast initial response time. And then I pause again, we can show the main content, which is the text here, for example, but we can deprioritize secondary content, like we see here in the sidebar and the stuff below. So we can prioritize the main content, so the users get the main content as fast as possible, and deprioritize loading of secondary content. So this is can be very nice for performance. And yeah, and then the secondary content pops in, and it looks the same as the multi-page application that we saw before. But we saw both of those approaches have a couple of downsides, even very severe downsides. And with single-page applications, we just explore the severe downsides, and a lot of us are dealing with those problems today. So how can we get improved performance, improved resilience, and improved accessibility without all the benefits we get from SPAs, for example? And my answer to this is we have to go back to the future. And by this, I mean we have to build PEHAs. And by that, I mean progressive enhanced hybrid applications. So instead of building multi-page applications or single-page applications that either run on the server side or on the client side, we can mix it. And by doing that, we can get all of the benefits, so we can eat the cake and have it too, basically. We can get fast initial response times, we can get progressive enhancement, so everything still works even if our client-side code breaks. At least for some of our users, we can get an app-like experience with the same features of an SPA, and we can also have resilience in those situations where something goes wrong on the client side. So let's take a look at the improved performance part. And for this, I put all three variants, so like the multi-page application, single-page application, and the progressive enhanced hybrid application side by side. And let's see how they load. And we see it pauses after 1 second. And for the SPA, we only see this loading spinner. For the multi-page application, we see nothing at all. And for the PEHA, we see as soon as we get the first response from the server, which basically leads for the SPA only for this loading spinner, because we don't have any data yet. For the PEHA, we already have enough data to render the main content, which is a very nice user experience. And I have to say this is on a simulated 3G network, so I think it's very impressive to get a result after 1 second. And then also for the progressive enhanced application, the secondary content pops in. Let's start from the beginning again. So we see the secondary content is still loading, so we only load the main content server side, but the primary content is very fast, and we get the result, the complete result, also even faster than with a single-page application, because we can start loading even the secondary content on the server side. So how can we implement this today? And today there are a couple of frameworks, but I want to focus on two. I think the most important two frameworks with which we can do this today. And the first one is Svelte, which is a meta framework for Svelte. Svelte is a JavaScript framework similar to Vue.js to some extent, but also similar to React in some ways. So how can we do this in Svelte? How can we load data most efficiently to get this awesome performance we just saw in this video? And in Svelte, we have loader functions, and these loader functions load all the data we need to render a page. And here we can see this profile data is on the first, is not nested inside this object we return from the loader function. And profile service get by user ID returns a promise. And Svelte will await this promise on the server side. So the server will not respond with any HTML until it has fetched or it has resolved this promise, because the profile data is the main data we want to show immediately. And everything we nest inside of a property, like here the stream property, but the name isn't really important here. I just named it streamed because it makes it a little bit more clear. Everything that is nested inside of a property in the object, all those promises in there are started on the server side, but we don't wait until they are resolved, but we ship the HTML immediately. And as you saw in the video, this is the secondary content in the sidebars. And we can show a loading spinner and show them the main content immediately, but we show a loading spinner for all those nested properties that we don't resolve. But the important thing here is we start loading immediately on the server side, opposed to single-page applications where we only can start loading data when the JavaScript bundle has finished loading and executing. So we save a couple of milliseconds or even seconds here. And then we stream the data. As soon as the promises are resolved, we stream the data to the client-side application. So here we can see a template rendering, for example, the page we saw, a simplified template where we have those profile data lines. So the main content we render immediately, but all the secondary content we have to await, and we can show a loading spinner, you can show an animated SVG or something like that. I just chose the simple route, and only when the promise has resolved and the response is streamed to the client side, we show the secondary content as well. But Svelte is not very heavily used right now, although I recommend checking it out. Especially SvelteKit is a very good framework. But also in the React world, we have a framework called Remix. And Remix basically does the same, or let's put it that way, SvelteKit basically does the same as Remix, because I think Remix was first. And in Remix, we also have those loader functions, which we declare to load all the data for a page we want to render. And in Remix, we can use a defer helper function. And what this defer helper function will do is that it also streams all the promises that are not awaited on the server side will be streamed to the client side. So here we see we await the main data, so the profile data we want to make sure is ready on the server side, so we can ship the most important bits of our HTML directly to our users. But interactions and posts, so the data for the secondary content, those promises are not awaited, and we have to, again, do something like this here to show a loading spinner on the client side. So we have this use loader data hook, which we can use to get the data that we declared in this loader function. And then we can use suspense to show some fallback content, in this case, this simple loading text. And then we have an await component provided by Remix, which we can pass a promise, and then we await the promise, and when it is finished, we show the content. And in the meanwhile, we show the loading spinner as declared in the suspense hook. So much for how we can improve performance using this architecture, by example with Remix and SvelteKit. But now let's take a look at the improved resilience part. So to come back to the example from the beginning, where we had an e-commerce shop that my mother wanted to use to buy a vacation or to book a vacation. If we build our application with an SPA stack and there is some JavaScript error, and we click on confirm order, for example, then you can see we get the JavaScript error here, and we get exactly the same result as my mother got, a blank page. But because with those frameworks like Remix and SvelteKit, and with this progressive enhanced style of building your application, we have a different behavior. So here we have the same checkout page, but now built with Remix. When we click confirm order, we see everything works correctly, although it might not look perfectly right because it's only rendered on the server side, so we don't have any transitions or anything like that that we defined in our client-side logic, but at least it works, although we have the same JavaScript error as before. So your customers are happier because they can actually buy what they wanted to buy, and you or your boss will also be happier because they make more money and they don't lose any money. So much for the improved resilience part. So our applications work without any JavaScript at all. So if anything breaks, it still works as expected. But we still get the same benefits of SPAs, because if the JavaScript actually works, which should be the case for most of our users, everything is fine and everything will behave like a real single-page application. But now let's come to the third point, in which progressive enhanced hybrid applications help us to improve the experience for our users. And that one is by improving the accessibility of our applications. Why is that? So at the beginning, I showed you this example of a div that was used as a button, although it would be better to use a real button element. And here we see the same, like a form, and we have an input field where we bind an onChange event handler with JavaScript, and then we have a div on which we bind a handle checkout event handler, for example. So we misuse the div as a button. And this is a problem for accessibility, because that way it won't work if our users try to use the application using a keyboard, for example, or some other assistive technologies. But if we use Remix or SvelteKit, this example is from Remix, then everything is just a regular HTML form apart from this form component here. But this form component also renders a form, a native HTML form element, but it does some magic, so we get still all the benefits of traditional single-page applications, so we don't have to do a full page reload whenever we submit the form, and we can do validation and stuff like that. But at the end, everything is just an HTML form. So we have an input field where we have a name property, and then we have to use a button element, because otherwise, if we don't use a button element here, we would not be able to submit the form, because there are no event handlers or anything like that. So this is how Remix forces us to do the right thing, because if we don't do the right thing, it won't work, and it would be much harder to implement this doing it the wrong way than doing it the easy way. And that way, this form also works perfectly on the server side. And on the server side, we have an action that handles all the data for us. And in case I want to make this clear, in case the JavaScript works as expected, this still works like a regular single-page application. So there won't be a full-page reload, and you can do all the validation magic and everything like that. Okay, so by building progressive enhanced hybrid applications, we get the improved performance we want, we get improved resilience, and we get improved accessibility. So I urge you to go ahead and build progressive enhanced hybrid applications and make the world a little better for everyone. So my name is Markus Oberlehner, and if you want to, you can check out my Twitter. I'm also writing a test that might or might not be relevant for you. It's about writing tests for Vue.js application, although what I write in there is also relevant in general for web applications in general, I would say. And if you want to give feedback, you can go to DevConf, CA, rate Cape Town, and rate my talk or the talks of the other speakers. So I can see there is some time for questions, so let's do this.
Thank you. Where does something like Next.js fit in? Because with Svelte and Remix, if the server requests are started prior to the HTML being sent, then it'll be obviously faster. Is that the case?
Yeah, so Next already does some of the things that I showed you here. So it does the server-side rendering, and you can use it in a way that you also get the benefits or the resilience benefits. So you can build pages in a way that you also can submit forms and they will work even when JavaScript fails. But it's not by default. And when I was starting with this talk, it wasn't really designed for this at all. You could do it, but in the documentation and everything like that, it wasn't really the default, let's call it that way. But with the latest release of Next.js, they did some things that are very similar to what I showed you today, where it is easier to also do this with Next.js. But I would still say that the point of how Remix, for example, makes it harder to do the wrong thing, that's still not true for Next.js, I think. So I decided to leave it out. But you can have the same properties with a Next.js-based application as well.
Thanks. So in my case, I often wait for the client to load and then I make requests. So I didn't mention that. So for something like Svelte, does the client load first and then make requests for additional data, or is those requests started as the client is loading?
Yeah, the request is started on the server side, immediately on the server, and that's what makes it so fast.
Hi. Thinking about the kind of practices you're advocating, how much cooperation do you need from the designers on this? It's very easy to imagine them designing something where it doesn't respect this, so it becomes against the grain of the framework that you implement.
So usually I think the default is always the same experience as with single-page applications. So in that regard, I think it won't be that much different for the designers, only if you really, there are two modes or two routes you can go. You can go the route of saying, I really want to nail this progressive enhancement part, and I want to have also a nice user experience, even if something goes wrong. Or you can treat it more as a fallback. At least it works, If it looks decent or not is not that important for the fallback route. Then you don't have to consider it for the designs at all, I think. And even if I think the difference for the designers is minimal, I guess. Either way, I think.
How important is pre-rendered HTML for SEO?
Yeah, that's a good question. I think the general thinking still is that if you want to have good SEO, you should go for pre-rendering HTML in any case. I'm not quite sure if it's still true, but probably if you want to be safe, better safe than sorry, so probably it's still better. And it's also better because at least if you have, like the company I work for, we have like a huge amount of URLs which we want Google to scan. And if you have a lot of URLs, you run into troubles like the Google bot. You have a budget for crawling. And in that situations, I think I would always go for server-side rendering because it is faster. Because with single-page applications, you always have this delay when you have to download the JavaScript bundle. And with server-side rendered applications, you don't have it. And I guess that it's, if you have a lot of URLs and you have to watch out for your crawling budget, I think it's always the best way to go with server-side rendering.
You mentioned that by default you fall back to single-page applications as your standard. What are your thoughts on the inverse as an approach to progressively enhanced apps, in that the server-side render is the initial approach, and then something like a single-page app framework like React injects itself, and then your application is still fully serviceable without JavaScript, but gets enhanced through JavaScript?
Before I get to this question, I have to clear something up. Maybe I said it wrong. My default is not to go back to single-page applications. The default is the single-page application, even when you go the experience you get from a user point of view is the single-page application, because when JavaScript loads, everything behaves like a single-page application. So that's what I meant. And to your question, today I talked to some other speaker, and we were talking exactly about this, where he said he thinks it makes a lot of sense to go back to default to multi-page applications, because what I hinted at with the complex code base, you can get the best results by building single-page applications. You get this app-like experience, and you can get the best results by following this approach, but having a lot of JavaScript, basically, writing a lot of React code and stuff like that. If you do it well, you will have the best experience that can't be matched by multi-page applications. But it's very hard to do it that well. It's very hard to get developers that are skilled enough to build maintainable React applications, large-scale React applications and stuff like that. So depending on your circumstances, depending on how many experienced React developers you can attract, it might make a lot of sense to default to multi-page applications, because then a lot of things might be easier from a maintenance point of view. And then you can go ahead like in the old days, basically, where we had jQuery or something like that, and add progressive enhancement on top. I don't think that React and Vue.js and maybe Svelte a little more, but I don't think they land themselves very well. Because with jQuery you always had the server-side rendered code, and jQuery took over basically, and with all those client-side frameworks are more designed to render everything from the start and don't really take over, although we do it with this approach as well. So I think it might make a lot of sense, but I think unfortunately there's not a lot out there to follow, but it's worth a try, I guess.
Sorry, just on the complexity as you're debugging the application, knowing where on earth this script is running. Is it on the client or is it on the server? Have you got any advice on just how you go about the diagnostics?
Yeah, there are different patterns that different frameworks follow. So, for example, in Next, I think it's in Next.js, where you have this .server ending for some stuff, and also in Svelte you have this as well. You have files that are named .server for code that only runs on the server side, but with a lot of those frameworks, be it Next.js, Svelte, Kit, or Remix, a lot of the code runs both server-side and client-side, so this is always something you have to keep in mind and deal with, I think, that it can be in both, that it can run in both client and server-side. Did this answer your question?
Yeah, I'm just playing with Remix, and that is one of the sticky points that I hit. And you're debugging with your browser console open, and you're looking at your server-side console, and you're just figuring between the two. Yeah, it just gets tricky.
Yeah, I can see that, but I don't have an answer how to improve it right now, but maybe it will be improved. Thank you for listening.